Have you ever just stopped and noticed how the world around you is getting, well, smarter? I mean, from the watch on your wrist to the traffic lights on the street, there's this quiet revolution happening, and it's connecting our physical and digital worlds in ways we've never seen before. Today, we're going to pull back the curtain on this incredible force, the Internet of Things. Okay, think about it for a second. Your car, your city, and your health. They seem like completely different worlds, right? But what if I told you they all share this common, invisible thread? That thread is the Internet of Things, or IoT for short. Today, we're going to untangle exactly what that means. Let's dive in. So, when most of us hear IoT, our minds immediately jump to a smart speaker yelling out the weather, or maybe a connected thermostat. And yeah, you're not wrong. That's definitely part of it. But trust me, the real story here is so much bigger and honestly, so much more profound. At its absolute core, the IoT is all about giving everyday objects a digital voice. It's about embedding tiny sensors and software into, well, everything, allowing them to gather information from the world around them and then talk to each other, all without a human ever having to press a button. And the sheer scale of this is just mind-boggling. This goes way beyond making your home more convenient. We're talking about agriculture, where soil sensors are totally changing how we grow food, or healthcare, with wearable monitors that track our vital signs in real time. IoT is the engine behind smart factories. It's the brain in intelligent cities managing traffic. And it's the very technology that's making self-driving cars a reality. To really get a feel for the power of IoT, let's move past the big ideas and look at some incredible real-world examples that are literally changing lives as we speak. Okay, this is amazing. There's a project called ARDA, which uses AI-powered cameras to scan a patient's retina. It can spot diabetic retinopathy with incredible accuracy, which means doctors can step in early and literally save a person's sight. That's IoT in action, a connected camera collecting life-changing data. And check this out. There's a device that uses thermal analytics. Basically, it creates these super detailed heat maps to detect breast cancer in its earliest stages. It's non-invasive, it's affordable, and it's portable. You see, this is a connected device that brings top-tier diagnostics to way more people in way more places. This is the human side of all that data flying around. Because at the end of the day, the technology is just the tool, right? The real mission, the whole point of connecting billions of these things is to solve real human problems and build a better world. But that brings up a really important question. How does this whole thing actually work? So let's peel back the layers and take a look at the engine that drives this entire IoT ecosystem. It's actually a pretty logical four-step journey from a simple idea to a real-world action. It all starts with the sensors. Think of them as the eyes and ears of the network, just gathering raw data. That data then travels to a local gateway, which is kind of like a mail sorting office, bundling it all up and sending it securely to the cloud. Up in the cloud, these massive supercomputers crunch all the numbers, looking for patterns. And finally, that analysis gets turned into something useful, an alert on your phone, a change to your thermostat, or a city manager's dashboard lighting up. Okay, so you've got billions of different devices made by thousands of different companies. How on earth do they all talk to each other? Well, they need a common language, or maybe more accurately, a few common ways of having a conversation. It pretty much boils down to two main styles. First, you've got request-response. This is like a direct one-on-one chat. Your phone asks a server, hey, what's the weather? And the server answers. Simple. Then you have publish-subscribe. This is more like a broadcast or a group newsletter. A temperature sensor just shouts out, it's 72 degrees, to a central hub. And any device that cares about the temperature, like the thermostat, is subscribed and gets that message instantly. And these conversations happen using very specific languages, or what we call protocols. Now, don't worry, you do not need to memorize this list. The point is just to see the hidden complexity. For example, Bluetooth Low Energy is perfect for something short range, like your fitness tracker talking to your phone. But LoRaWAN is designed to send tiny bits of data over miles and miles for something like a smart farm. Each protocol has a very specific job, balancing things like range, power, and speed to make the whole network run smoothly. Now, connecting everything in the world to the internet sounds awesome, right? But it comes with a gigantic challenge. Every single one of those billions of connected devices is a potential door for an attacker to walk right through. So to really get a handle on this risk, you gotta know two key terms. The attack surface is basically the where. It's the sum of all the possible entry points. And in IoT, this surface is massive. It's your camera, your car, your city's power grid.
Then you have the attack vector. That's the how, the specific path or method an attacker uses to actually break in, like guessing a weak password or finding a bug in the code.
And some of these methods are surprisingly clever. An attacker could literally just steal a sensor to take it apart and figure out how it works. They could flood a city's traffic network with junk data to shut it all down. That's a denial of service attack. They could even spy on a device's power usage to steal its encryption keys. Or, and this is a scary one, they could intercept a signal from a factory sensor and change a normal reading to critical just to cause total chaos.
So, how do we fight back? Well, it's all about a layered defense. To keep data secret, we use encryption to scramble it. To make sure that data hasn't been messed with, we use digital signatures. To verify a device is who it says it is, we use authentication. And to spot trouble as it's happening, we use smart intrusion detection systems to watch the network for anything suspicious. Okay, so security is one huge piece of the puzzle. But just managing the sheer, mind-numbing complexity of a billion devices is another. The traditional way we've been building networks for decades, it just isn't going to cut it. We need a totally new approach. And this is the beautifully simple idea that could solve the whole problem. Imagine if you could just pull all of the decision-making intelligence out of every single router and switch and put it all in one central, programmable location. Here's how that works. On the left, you've got a traditional network. It's decentralized chaos. Every single router is making its own decisions. On the right, you have a software-defined network, or SDN. It has a central controller, the brain, that sees the entire network, and it tells all the simple hardware devices, the body, exactly what to do.
And the benefits for IoT are just enormous. With one central brain, you get total control to program the whole network at once. Security is way better because you can spot and stop threats from that single viewpoint. It lets you scale up to millions of devices, easily reroute traffic if a sensor fails, and even manage power more effectively. In short, it makes the network smart, not just the devices on it.
And this is really the key takeaway for the future. We just can't rely on millions of tiny, independent brains all doing their own thing. To build a truly robust, secure, and scalable Internet of Things, the network itself has to become the intelligent, orchestrating force behind it all. Look, the Internet of Things isn't science fiction anymore. It's the architecture of our modern world, and it holds this incredible promise for a healthier, more efficient future. But as we connect everything, we also create new vulnerabilities. So the ultimate question for all of us is this: as we build this smarter world, how will we balance that amazing innovation with the deep responsibility to make it a world we can truly trust?